Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. Hey everyone, and welcome back to the HFE Hub. Today, I'm chatting with Sam Gerges, who's a qualified physiotherapist, ergonomist and occupational health and safety specialist with over 15 years' experience working in Australia, Japan and America. He's experienced across many industries, including manufacturing, oil and gas, forestry, retail and logistics. And Sam possesses expert practical knowledge of ergonomics and human factors, processing equipment and plant design, hazard identification, risk analysis, control implementation, compliance and auditing, to name just a few. So Sam, it's so great to chat with you today. I know we've been trying to organise this podcast for some time. So finally we're in the same, or not quite in the same room, but almost in the same room. So it'd be great, firstly, to probably chat about your background and what you've done. Tell us about yourself.
Yeah, sure. So thanks for having me on this time round, and sorry that it's taken so long for our schedules to align. Bit of background about myself. I started off as a physiotherapist, and I got pretty much into private practice from the get-go. And I used to see a lot of work cover clients. Maybe 67% of my patients were work cover clients. And so I started to offer to employers, hey, if you're sending your guys to me for rehab, why don't I come into your workplace and see why they're getting injured. And I really loved that injury prevention work. And so I had the opportunity to continue and study ergonomics. And then I've been consulting in the ergonomics field for the last 15 years or so. It's kind of taken me all over the world. I've been able to consult in the US and in Japan, as well as Australia, and across all different types of industries, ranging from manufacturing, which is kind of like my blood and sweat into there, and then but also across pharmaceuticals, agriculture, transportation, rail. Like, it's kind of taken me all over the shop. So it's been great working as a human factors and ergonomics professional. It's kind of like giving me that broad kind of expertise, and then being able to apply it in all different scenarios in different ways has been a real blessing for us. Yeah.
So tell me about some of the projects that you've worked on, given that there's manufacturing, agriculture, so many things you've mentioned then.
Right. So some projects that I wanted to kind of talk about today is probably in the manufacturing space in regards to automotive. I've got a really strong automotive background and have been working with Toyota for over 11 years, working across all different parts of their manufacturing facility. So I wanted to touch base on what that kind of looked like. And so when I first started with Toyota, is when they were manufacturing here in Melbourne. And it was myself and one other person, Belinda Margus, who was there before me, who started the rollout of an ergonomics program at the plant. There wasn't one that was there previously, and Belinda was definitely the strategic expert here, where we thought for a rollout of an ergonomics program to be successful, we really need to prove its worth first. Toyota takes on a very logical approach with everything, as we know, and so being able to prove its worth, there's this Japanese targeted approach. It's called Genji Genbutsu. It means you go and see. Okay, you go and see. And so it's about being able to go to the source of a problem and being able to visually see, discuss, consult, and work out a solution. And so we knew we had to take on that same kind of approach for ergonomics. And so we started off with a pilot of 10 tasks where people were working on the assembly of a vehicle. And we consulted with the managers of the plant and the team leads, let them know what we were doing, got them on board with what the benefit would be for them. And then they said, okay, like let's work on getting 10 tasks assessed and understand what the risks are there and some controls. And so we assessed those tasks. We were able to identify key issues. We obviously also interviewed team members and we're collecting data, like injury data from there as well. And so we then held control meetings where we would come together and discuss and decide on what controls we would get. And at the end of all that, we were able to get some controls implemented with the sign-off of the engineers and the managers. It proved to be very successful, the pilot. And so then we got an opportunity to present this to the higher-ups and then got approval to roll this out across the whole manufacturing facility. So we started off in the assembly plant and then moved across into the body shop, press shop, powertrain where they build the engines, and paint shop as well. And so we started rolling out the program across the board. It took a lot of upskilling and a lot of buy-in of key stakeholders to get this up and running. And we established ergonomic champions in all the shops so that they would then be able to run the program themselves and not need to be continually handheld by us being the core ergonomics team. From there, it kind of just blew out from there. So we started off with the repetition, the repetitive tasks that are done in manufacturing, and then it then moved across into the non-repetitive tasks. So we started assessing things for maintenance, and then it jumped across into the material handling space as well. And so we were able to grow the program over a number of years to not only encapsulate all the things that are done in a repetitive kind of stance in manufacturing, but also those ad hoc and non-repetitive tasks. And a couple of years down the track where we had this all up and going, that's when assembly, we worked very closely, obviously, with the stakeholders and kept in contact with them. And the assembly plant then said, hey, let's actually take a step back, because every time we talk about controls, we talk about fixing the design of the parts, but we never have an opportunity for that. Now we're about to start a new model project. Let's get involved. And so we jumped at that opportunity, and we really got down into the crux of how we can impact the development of musculoskeletal injuries through the development of part designs. And we were able to successfully run with the design process in Australia, and we were able to successfully roll out a Camry and an Orion and the hybrid Camry. And unfortunately, that's when Australian automotive manufacturing kind of closed the doors. And so Toyota US contacted me and said, hey, like, we know of the work that you're doing in Australia, and a lot of our tools were based on the US tools. We'll talk about that. And they said, hey, why don't you bring your expertise up here? And so my wife and I, newlyweds and nothing really holding us back, we decided to jump ship and we moved to the States. And I was managing the new model ergonomics programs there across all of North America. And so working across the different state lines and having a team of ergonomists who were managing the new model projects, we were able to really make the system robust in how to implement ergonomics within the design process. And so I thought it would be interesting to talk about that a little bit. What do you think, Sharon?
Absolutely. I was just going to go there. So tell me about how you did that.
Right. So all the learnings from Australia, what we found was that getting the buy-in and consultation of all the different stakeholder groups was paramount to the success of making any kind of design changes. It wasn't only about getting the production members on board who would actually build the car, but more so the quality engineers, the system engineers, and also all of the designers as well. And so we wanted to make sure that when we were coming up with solutions, it wasn't only about impacting the biomechanics of how someone fits a part. So it wasn't only looking at the force or the weight or the posture or the frequency or duration of how things are held or how often. Not even looking at specifically the tools and the vibration of the tools. But it was also about making sure that by implementing these changes, we were also able to impact the quality of a part, making sure that it improved the quality. the productivity and the repeatability of how things were put into place. We had to make sure that it ticked all the boxes, and if it didn't, it wasn't a good solution.
Can you give us an example of one of the steps in the manufacturing process that you targeted, and maybe break that down for us?
Yeah, absolutely. So one of the bigger parts of the design process is understanding how the parts are going to behave before the parts are actually designed, or rather than design, manufactured. And so we would analyze the parts firstly in a 3D model, okay, using CAD data, and we would see how the different parts fit together. Okay, and so we would have some kind of analysis of what kind of postures people would be in, and we would look at it across all kinds of anthropometric data, right? We'd look at the different postures, the different clearances, understand what the visibility of a worker would be like, and how that would impact someone, the order of installation of parts, and then how, when parts overlap, what the forces may be. And it was really important to understand or consider the variation in manufacturing, because when they make a part, right, let's say they were making the glove box, how the glove box interacts with the instrument panel at the front, clips and screws have to go into that area. And depending on how much overlap would impact the force, right? More overlap, more force. In 3D data, we would get what is called nominal, right? That's if everything was perfectly created, this would be the condition it would be. But we understand that when things start to get manufactured, all right, from suppliers, there's variation in what they can provide, all right? And so some parts would have the really large variations, and other parts would have to be really, really small variations. So if we're talking about, for example, a body stamped part, all right, that variation might be 0.2 millimeters. When we're talking about things like wire harnesses, it can be up to 10 millimeters. All right, and that doesn't really sound like a lot, but when you're talking about adding all of those differences across a whole vehicle, that can make a whole lot of difference. And so this came about in lots of different ways. There was, for example, the handles that go on the roof of the vehicle, all right, for you to be able to adjust yourself when you're sitting. If there was variation in how the body was, in how the headliner is, in how the part was manufactured, in how the clips were oriented, then all of those things added up to forces where at nominal, it might come in at 4 kilos. But in reality, through the manufacturing process, we saw forces up to 30 kilos. And we would take these measures using the force gauge, right? And different types of force gauges. So we had spring-loaded ones, we had tension-type ones, and we even used electronic pads. And so we wanted to make sure that there was consistency and reliability in all the studies that we did as well. Because when you're talking numbers, the first question is, well, how do we know that that's the right number? You've got to double-check it. And so we made sure that was built into the process as well. And so moving from 3D analysis to 2D analysis of the parts was a big step for us. And that was something that was done really well in the US previously. It wasn't something so strong that we were doing in Australia. So that was a big learning part for me in understanding how the variation in manufacturing and setting out specific specs on the 2D drawings to define how parts should be fit together. I think that was a really critical step for us.
So you've got variations in the parts, therefore it changes the overlap, therefore it changes the force, and so then you're changing the way those parts fit together. So you might change the design of how they fit together. That's what you're saying, isn't it?
That's right. Yeah. And we would look at the type of overlap, the shape, the types of material, the amount of flex, the amount of support that each clipping point had, depending on the posture and the way that forces had to be driven. Then we would also look at how force distribution occurs. It was a really deep analysis throughout the whole process. And so these kind of things, they don't take just a day or two. Like it's months and months of assessments. And when we provide our feedback, the designers would take that on, consider it, make changes, and then feed it back again. And then it's reviewed a number of times. And so there's this continuous consultation and communication done between all the different stakeholder groups. And we were just that one part of it, right?
Yeah, that's actually really exciting, because I imagine that the worker is in at that point as well. So in years gone by, they will have got used to just adding a heck of a lot of force to join two parts together, and suddenly, obviously, those forces are changed. So, so I'm assuming that users were in with you working on this as well.
Toyota did a great job with this. So the users, the actual builders of the vehicle, are at the core of this process, and their voice is extremely strong, and like everything has to go through them before it goes anywhere else. And so they are by far at the core. There's a really strong understanding that that the worker is the key here, and their feedback, because of their experience in the role, and their understanding of how the tasks are put together, that they're really the key, the key, or the glue of the group, if I could say that. And the great thing with that as well is that because of their experience, they've got a lot of learnings, right?
So the user is the glue.
They're the glue of the group, and because of their experience in the past, with the background of incident data, quality data, their experience in how tasks should be put together and how like the different areas align, all of those learnings are brought into the project for consideration as well. And then once we do that analysis in the 3D and 2D worlds, that's then when they prototype parts. And so they prototype critical parts, and we check that on a 100% perfect body. And then we provide feedback on that before we can then start building our own confirmation vehicles. And that's really the first time that vehicles are produced. And it goes through this design group for us to be able to check for the first time on actual parts. And so the production guys are checking all of their productivity items, how the order of how parts are put together, the sequencing, the timing of it all. Every second is counted to understand the timing of how the vehicles are to be put together. The quality engineers are doing all their checks. Obviously, us from the ergonomics and safety side, we're all doing our checks. And that's the first time we're able to take real force measures on real newly designed parts. And we meet with the designers on a daily basis and discuss all the findings. And then we all have to come to an agreement of changes across all the stakeholder groups. And if there's not that unanimous agreement of the direction, then we stay back until we figure it out. So definitely during CV timing, confirmation vehicle timing, it's always long hours, and the psychosocial side of the role definitely kicks in.
So the idea with the confirmation vehicles is, the idea of mocking up the design, which is brilliant. I just wondered, were all the parts that were installed in the vehicles at the times that you were working on these projects manual? Because I'm thinking, what kind of toolage needs to be redesigned when you redesign a part?
Great question. And so for the confirmation vehicle, things were definitely done manually. However, because of the certain parts that we knew were coming in, automation and having mechanical aids for some of these parts was also like in conjunction being designed as well. Okay, and so so as we're assessing the parts in 3D models and 2D models, we're also thinking about what kind of new equipment and new plants are we going to require for installation of some of these things, and whether that new plant or equipment is talking about how parts are handled or how the human is handled. And so, like, there were things where humans would have to sit on seats that can enter and exit the vehicle. And so the design of that kind of plant and the type of framing that involves was also part of the design process. And on the other side, things that could handle things like bigger parts, like engines and headliners and things like that. So all of that was considered. So
did you use, you've talked about 3D and 2D analysis. Any other kinds of tools that you used in that process?
Yeah, we used virtual reality as well. And so we used, for virtual reality assessment, we would mock up the CAD drawings into a manufacturing environment, and then being able to assess different types of people and different types of scenarios on how things are done. And so we use that. Toyota also has their own validated and quantified ergonomic assessment tool. And so we were able to further that and tailor it for the manual handling side of things. We would use different tools for data entry and data analysis. And we used other technology like motion capture. And so Velocity EHS were a group that were consulted to bring in motion capture into the area. And with that, you would just point the phone and be able to record someone. And then it would provide you with an analysis of what the different postures, and you can enter forces. And it was a really quick and easy way for us to be able to understand this is how current condition is. And if we were to change that, what the impact may be.
For that analysis, I imagine that you would have used lots of different people doing it and looking at all the different ways that the work is done.
Right, absolutely. So from start to finish, when we're talking about a new model project, it takes between 2 to 3 years. It's not a small project, and over the last 11 years, we've maybe covered 15 vehicles, or that I've been able to be part of and overlook. That's over like the Toyota range and the Lexus range. And obviously that takes a lot of resource effort, right? And so we had the core ergonomics team who was kind of coordinating the ergo efforts. And then we had different ergonomic champions from different groups of how the vehicle is built together. So there were people that were involved with dealing how the frame of the car, the chassis is put together, and the engine. There were some people that looked into the inside of the vehicle, others that where things get clipped onto the outside of the vehicle and the engine bay. And so we had champions for each of these sections as well. And then we also upskilled all of those core members who were part of that production team. So they had an understanding, a basic level of what the basic ergonomic standards were and what we were looking for. And then when they needed help, then it would escalate up the chain. So it 100% takes a lot of resource effort, and we understood that we wouldn't be able to take that on ourselves. But the upskilling of the stakeholders was definitely a big part of it. And the thing is, like, we can't impart everything, right? And so we also developed design guidelines so that they had kind of like a line in the sand where they would say, okay, this is okay versus not okay. And that was definitely really important when we got into the conversations with designers, because they need to know a hard target of what they were aiming for, not just reduce as much as possible. We worked on getting those standards accepted at a global level. Japan has their own standards, and there's always a little bit of back and forth with gaining agreement. However, on the most part, while I've been working with them, like, we've gotten to a really good mutual understanding of what those basic guidelines are. And then, taking those standards and turning them into global standards was definitely, from the system side of things, a big achievement for us.
Wow, this project sounds amazing. And I guess the culture in Japan is a bit different to the culture in other countries, and I think they would have welcomed these changes more readily and be more willing to give things a go. Am I right thinking that? Or
yes and no. So they definitely take on a Kaizen approach. Kaizen is another Japanese word. It means continuous improvement. And so they always take on that approach, so that it can always be done better. And so having that as a foundation belief was critical for us. But then there are also the challenges, like when you're making these kind of changes, right? Doing it to drawing phase, it costs very little, all right, to make a drawing change. You still have to justify it, but you're not battling the cost argument. Once tooling starts to make parts, that's now a much harder argument. And of course, there are things where you don't catch them on drawing phase, but you catch them after parts are first being developed. And so there's always the challenge of fighting costs and also quality and productivity. Like, if you can imagine, like a clip going into a hole, the larger the hole, the lighter it's going to be. But that also means it's not going to hold as much. Okay. And For some things, we want them to hold really well, and other things we don't mind if it's a little lighter, right? So if it's like a small garnish inside the car, it's like we want it to be light, but we don't want it to fall off either. And if it's something near airbags, we need to make sure that it holds on, otherwise things are flying off. And so we ran into these kind of things when we would do crash testing, where what we thought was a solution was actually not so good of a solution for quality.
Sorry, I bet that revealed some interesting outcomes.
Yeah, absolutely. So you go back to the drawing board and say, okay, let's take a look at this. Yeah, slap it on. Let's go for the next part. But definitely, I would say that was probably one of the bigger challenges, in all honesty. Like being able to satisfy all the different stakeholders, it was a really challenging task. Having them all, though, buy in to understand that ergonomic changes aren't only for reducing injuries, but you also get productivity improvements and quality improvements, and in most cases some cost improvements, then like that, those kind of case studies we wanted to highlight as much as we can. So then with the next battles they say, okay, let's consider what these guys are saying a little more strongly. So setting some case studies and using that as examples to improve the culture.
I imagine that where you started, the design or the ideas that you had when you started on that first project are different to the way you start projects further down the line. Is there anything really significant that you recall in these projects that you started it in this particular spot, and then the second time you did it, you knew that was not right or useless or whatever and changed it? Or did you find that you always did it the same way?
No, we definitely found that the approach changed, and we had to strategically change our direction a number of times. This was probably most apparent when it came to global parts. And so parts that weren't just only for one particular vehicle in one region, but it was something that was carried across different models across different regions. Okay, so imagine there's the exact same part that's used on a Camry and a Corolla, that's in the US and also in India and also in Thailand, right? And so for parts like that, we could not approach the design through this normal design model, okay? Because those parts, they're carryover parts. They're called carryover parts. And so they carry over from vehicle to vehicle, from year to year. Those parts don't change like that. And so to impact those kind of parts, we had to take a completely different approach. And we didn't even know about this until we explored more with when we were working in Japan, that there are completely different design groups depending on those particular parts. And so it was kind of like a different kind of stakeholder engagement, which we only found out like not only after one or two kind of model runs, but it took quite a few before we found out that, hey, there are actually other people behind the scenes working on these exact same designs, but on a different playing field. And so for those particular parts, we had to put a completely different ergonomic strategy together to be able to address those and being able to make changes at a global level. And we were able to do that kind of work in the US.
So what did that look like, those changes? Are you able to say what that looked like?
Yes and no. So I'll maybe not go into so much detail, but as an example, there are certain parts that are fitted onto a door, onto a Toyota door. And those parts were used globally. And depending on the different shapes of the metal of the door, the forces to insert these were different. All right. So there were different profiles of the metal. There was different thicknesses, different ribbing. And so on really reinforced, like where the metal was really well reinforced, the forces were fairly low. Where the metal wasn't so reinforced, it didn't have as much ribbing, and there was a bit more flex in the material, then the forces were much higher. And so we had to come up with a design and a compromise to say, okay, where is that level of reinforcement to the vehicle without increasing the weight of the vehicle, without having too much impact to the current production lines. And so it takes a lot of back and forth and a lot of studies to come to an agreement with those kind of things. Also with connectors. So if you imagine you've got like a wire loom going through the vehicle, and the way that different connections are made from that wire loom, a lot of those connections would just be from vehicle to vehicle to vehicle, right? And so depending on if it's a watertight connector and it's got like an internal sealing structure versus a non-watertight connector. And with watertight connectors, some of those seals have lubrication on them, some of them don't. And so being able to argue the case of the different combinations which decreases the force and trying to make that a standard across all. And if there was a force that was too high, then what other connection structure can we use? Rather than a straight linear connection, can we use lever type connections where you've got a bit more of a mechanical assistance with that? The number of pins they use, the type of coding that the pins have. Like, it gets very technical with how deep the study goes. But to make that impactful change, like that's the kind of detail that we were able to get into. And at the end of it, like what we were able to achieve was amazing. Like, we made thousands of changes in these vehicles. In the 2018 Camry, we were able to reduce just under, I think, 2 tons of push force across the whole vehicle. All right. So it's not just like it might look like 0.5 of a kilogram here and like 2 kilograms off there and 1 kilogram off here and 5 kilograms off there, but adding it up across the whole vehicle, close to 2 tons worth. And so looking at that to what the exposure's like in the development of a musculoskeletal injury, like that was really good to see that we were able to make those kind of impacts.
So did you only change the parts? I'm wondering what else you changed and whether some of those changes were maybe organisational changes to the way things are done.
So organisational changes, I think that having definitely that kind of core group as the main support and facilitating group, but then giving the autonomy and the skill set to the people on the ground, the line workers, I think that was a really good approach that we took. Definitely from the strategic point of view, being able to, I guess, sell the programs, being able to show their benefit was something that we were able to then take from year to year, from contract to contract, to be able to resource effectively and help with resource planning from the organizational side. As you can imagine, as you go through like these project phases, there are times where like it gets really time sensitive and there's a lot of crunch time. And then there are some lower periods where it goes back into planning, reporting, data entry. And so I think from the organizational side, being able to manage those fluxes was something that can probably do a little better with, because there are those times where you're working 12 to 15 hours and you've got to be on for that whole time. And then there is that recovery period afterwards. If we were to maybe look at that again, it might be about how different stakeholders are engaged at different times. That may be the right way to do it. So more about organizational engagement rather than like structure. That might be maybe a different way to look at it.
Yeah, that's really interesting. You've mentioned obviously long hours, and I'm assuming that it's the hours that you're working at that point as opposed to the shifts. So did you make any changes, just while we're on the word shift, did we make any changes to the way they did their shifts, the length of their shifts, or anything to do with that?
Not so much with the length of shifts. We did lots of studies in regards to rotation and the impacts of rotation. We did a few studies on, not a few, a lot of studies on how different parts of a task should be grouped together. And so everything that we've been speaking about so far has been about part design, but that wasn't the only thing that was being designed with a new model, right? So we had to design how, like the order of how these parts get together and then how you group those parts. And so we got a lot into process design, and we're able to do analysis on the processes. We're able to do assessments on the types of equipment that's being used and the plant layouts and the best way to reduce wasted movement. It's called muda in Japanese. So how to get rid of all of the wasted movements and make the movements as efficient as possible. So we did layout design, equipment design, plant design, process design. That was all part of that process.
The work that you did in rotation, what did you discover in that work?
Rotation, what we found does not, obviously, it doesn't change the level of risk in regards to the exposure to the hazards. And when I say hazards, I'm really talking about the biomechanical side of things, right? So however much someone needs to lift or the type of postures that they get into, the weights, the forces exerted, none of that changes with rotation. However, what does change is exposure levels, right? So by exposing someone less to them, then they, on a personal level, have less exposure to those hazards. And if they are rotated onto a role which uses different body parts, then those body parts do get recovery time. However, it doesn't fix the problem. It only changes the exposure level of individuals.
Well, the work is happy with some of those changes that you made. I mean, given that you've made lots of changes, what kind of feedback did you get from them?
Amazing feedback. And so we got feedback from it's never been this easy to install this part before, which is amazing to hear after all that hard work. Yeah. And then we've also heard, hey, this equipment is no good. Like we need to change this equipment because it's too slow or it's too gluggy or the bearings need to be like maintained too often. And so we definitely got a lot more wins than losses, that's for sure, but like they're still there as well. And it's not to say that you stuffed up. It just means, hey, like let's look for improvements on this because their feedback is important. And it's not just the voice of one, but like you're always going to have an outlier here or there. But we try to get consensus as much as we can, and we take objective measures as well to be able to back up that team member voice.
In the projects that you worked on, obviously cost is a big factor, and you've mentioned costs to make the changes. Did you see, and I'm not sure how long you worked on some of the projects, did you see some cost benefit in the long run in terms of injuries, not just production? So
with injury data, and cost of injuries, that definitely decreased over time. And we saw an average of, I think, $40,000 per MSD injury, and that went down to about 32. That was while we were in Australia. In the US, a little different. In Australia, also, like we took on self-insurance, which takes on a different kettle of fish. In the US, in terms of cost of the vehicle, we saw a decrease. In cost of injuries, we saw a decrease. And so, but it took a number of years before we saw that. It was where it becomes difficult is the breakdown of exactly which change caused that, and whether it was one or a culmination of a number, right? Because people installing parts, they only install one part. Right, it's a combination of parts, and depending on how many orders come through, they have to rearrange those, and so that changes over the years as well, or even over a single year. And so, being able to specify that this cost was associated with this change specifically was difficult to do. But we could say, okay, from the exposure of these parts, we were able to have this decrease. And so we were able to definitely get down to that level, which was really good.
Well, Toyota would have been pleased in the long run.
Yeah, for those changes, yes. But then also there were some cost ups for some of these changes as well.
Oh, okay. Do you want to tell us about where that?
We did end up with a net minus. So
the outcomes obviously are good from a cost perspective and an injury perspective. What are some of the challenges really that remained, or just that were outcomes that you weren't expecting maybe?
So there were some parts where either we caught them too late, and so to make the changes were just not feasible. There were some changes where we couldn't get to a compromise of quality versus safety, or find a solution which satisfied everything. So that was always a difficult challenge. And like I said, working on those global parts was also a challenge. So they were probably the three biggest ones. Working with like cost or quality or productivity or efficiency, those kind of conversations. We always tried to be as open and honest as we could, always tried to back our assumptions with data to say, okay, this is where like as much as we can be data driven. That was a key focus. And so talking about vehicle compliance, being able to obey like state regulations, like all of those needed to stay on board. So obviously we needed to ensure that was always ticked while these conversations were happening. I think, the biggest challenge was probably there are so many stakeholders and making sure that everyone knew what everyone else was doing. Like the project planning and communication had to be on point across the board. When there was a communication breakdown, that's when like some of these safety issues would fall through the cracks.
Of course.
Yeah,
okay.
And so whether it was we discussed an issue with the quality team but not the productivity team, or we discussed it with the productivity and quality team, but then the information came late to the designer. There was always a challenge with keeping all of the teams up to date because they all use their own communication platforms, right? That's hard to standardize across such a large organization that's global. And so being able to communicate with everyone effectively for every single issue, that was definitely a challenge.
Yeah, there's the time zone problem as well, isn't there?
Absolutely.
You probably were up 24 hours a day, Sam.
Almost. I remember we were doing some meetings in the States, and then I was taking a call from my walk-in closet because I didn't want to wake up my daughter, and then the next day I was jumping on a flight to head over to Japan. So it was fun times. I don't do that kind of work anymore, like over the last few years. So that's good.
So what's next for you, or what's currently for you?
So right now, I'm running my own consultancy, Absolute Care Group. We consult on ergonomics and safety for small to medium businesses and some large businesses, depending on what the project scope is. We're always looking for ergonomic projects to get involved with and bring in our expertise. So right now we've got a few projects that we're running through for some defence groups and some manufacturing facilities. So work's doing great, thank goodness. And And of course, we've got the physio practices, which are going well. Currently, I'm the Victorian Chairperson for HFESA, and definitely want to put out a plug for our Victorian members. We're always looking for new members. For students in particular, you guys are free to sign up and be part of the community, being able to interact with experts such as myself and with a ton more wealth than me. And so I highly recommend that you join and you're able to network with us. Definitely open up the opportunity for some professional development sessions and just have a good time. We've got in Victoria a pub night coming up in the next 2 weeks. So please come by, say hello, and we'll have a drink together and have a chat.
And I couldn't have said it better myself. And for more information, check out the HFESA website. Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.